Thunder. Check. Toy 1.
The trillion-dollar illusion. Inside a fighter jet that promised everything they said, it would change the future of air combat. A single aircraft built to dominate the skies for decades, invisible to radar, smarter than anything that came before it. A machine so advanced it wouldn't need to fight the way fighters used to. And it came with a price tag the world had never seen. Over $1 trillion. The most expensive weapons program in human history. This aircraft was designed to see first, strike first, and disappear before the enemy ever knew it was there. A flying supercomputer, a symbol of technological supremacy. But hidden beneath the promises, the simulations, and the speeches, is a contradiction so deep it threatens the very idea behind the aircraft. Because when technology fails, when distance disappears, when combat becomes chaotic and personal, this jet begins to struggle. This is the story of how ambition, compromise, and overconfidence created a trillion-dollar illusion. The origins of the problem go back to the 1990s. The idea was bold: replace almost every major fighter aircraft in service with a single design. One jet for the Air Force, one for the Navy, one for the Marines, different missions, different environments, different demands, all forced into the same airframe. Each service wanted something unique. Each request added weight, complexity, and dependence on software. Every compromise moved the aircraft further away from simplicity. What began as efficiency turned into accumulation. The aircraft grew heavier, the systems grew more fragile, and solving physical limitations increasingly depended on code rather than performance. The costs rose, the timelines stretched, but the explanation remained the same. This aircraft wasn't meant to fight old wars. It would dominate from a distance, beyond visual range, before the enemy could react. That idea works, until it doesn't. Because war is unpredictable. That unpredictability became impossible to ignore in 2015. A routine test placed the aircraft in a basic close-range engagement against an older fighter, a design it was meant to replace. The outcome raised alarms. The newer jet struggled to maintain energy. It couldn't reposition quickly. It had difficulty pointing itself effectively during high-stress maneuvers. The older aircraft repeatedly gained the advantage. This didn't mean the new jet was useless. Modern air forces don't seek dogfights. But history has a pattern. Missiles malfunction, sensors degrade, electronic warfare disrupts visibility, and when advanced systems fail, pilots are left with physics. At close range, computing power becomes irrelevant. What matters is control, agility, and momentum. The aircraft wasn't built for that fight. Not by accident, by choice. That choice came with consequences. The second problem isn't about combat at all. It's about cost. Buying the aircraft is only the first expense. Operating it is the real burden. Maintenance is complex. Parts are proprietary. Repairs depend on a global digital logistics system that has repeatedly failed to deliver. Availability rates have fallen short year after year. Jets sit grounded not because of damage, but because of delays. Spare parts, software approvals, contractor dependence. The military does not fully control the aircraft it flies. This creates a vulnerability no enemy missile needs to exploit. In a real conflict, disruption of supply chains and communication networks is inevitable. And when that happens, advanced technology becomes a liability rather than an advantage. An aircraft designed to dominate the future becomes trapped by it. And then there is the promise that has yet to arrive. The aircraft was never finished. Its most important capabilities are locked behind a long-delayed upgrade. New hardware, new software, and new processing power. Without it, the jet operates below its intended potential. Systems lag. Stability issues persist. Crashes and resets have been reported even in flight. The future version of the aircraft has been perpetually just a few years away. Those years have turned into decades. This is the paradox. A jet built for tomorrow, struggling today. A system so advanced that it cannot function without constant updates. A supercomputer that cannot afford to fail, yet sometimes does. This aircraft is not a failure because it lacks technology. It is a failure of compromise. It tried to be everything, and in doing so, became dependent on assumptions that war does not respect. It excels at long-range dominance, yet risks vulnerability up close. It represents unmatched innovation, yet suffers from readiness problems. It promises the future, yet continues to wait for it. The real question isn't whether this jet can defeat an enemy aircraft. If you enjoyed this in-depth analysis, make sure to subscribe to Force Strategy and hit the bell icon. That way, you won't miss any of our upcoming deep dives into global strategy, military developments, and expert insights. Stay informed, stay ahead, and join us as we explore the forces shaping the world.